Okay, I hope there's enough lighting. Had to restart this video, but we're gonna still be in 1.7, and we're gonna still be solving inequalities now. But we have to remember, when you're solving anything, it's very similar to when we're solving equations. What I mean by that is what you do to one side, you have to make sure you do to the other. And I started with this inequality, so let me cover everything just so you guys can see it happen. So I started with this inequality here, just 4 greater than or equal to 2. And this works with any of these inequalities. It doesn't matter which one, it works with any of them. Now, all it is, you want to make sure it starts with a true statement. So 4 is greater than or equal to 2. That's completely true, and you could use any of the other 3 to start off with. So like I said, to balance an equation, but now we're going to be doing an inequality, I'm allowed to add 2 to both sides, and that doesn't change anything. 6 is greater than or equal to 4. That is still true. I can also subtract by anything. So that's subtract 3 to both sides, and that leaves me with 3 is greater than or equal to 1. That also doesn't change anything. I can also multiply by 4 to both sides, and that gives me 12 is greater than or equal to 4, and that doesn't change anything either. This is still a true statement. The numbers, of course, are changing, but this is still a true statement. I can divide by 2, and that just leaves me with 6 is greater than or equal to 2, which is still very much true. Nothing's changed here. And again, don't worry about how they're changing. Everything's still the same. Let me fix this. But what does change, so let me start up here again with this 6 is greater than or equal to 2, is if I want to multiply, let's say multiply if I want to multiply by -6. So I'm multiplying by -6 to both sides. What that gives me is -36 is greater than or equal to -12. Now, let me turn the light back on. Okay, great. Now, if we go back, if you saw the previous video, remember, bigger numbers are on the right, smaller numbers on the left. 1 is smaller than 2, hence it's on the left. When it became to negative numbers, that idea is like even though on this side 2 is bigger, but on the negative side, the -2 is the smaller one and the -1 is the bigger, because numbers on the left are bigger than numbers on the right. So if I look at this number here, so -12, if I make a number line, I keep extending this number line to, so if we look at that -12, sorry, I paused the video really quick. So if you're looking at a number line, so we got that idea out of the way. Here would be 0, and then you'd have a bunch of tally marks. You get at -12, but then this would be -13, and then you have to keep going till you eventually get to -36. So -36 actually is on the left of -12. So that means right now this number is the smaller one. Even though, remember, this notation, we go back to our last video, this is the bigger side, that has to be the smaller side. So that means this statement is false. The only way for this statement to be true is you have to switch it. Since I was using the equal to one, I just want to use the opposite of that one. So I'm just switching it around. And now it's good. So whenever you multiply by, so everything, adding, subtracting, multiplying, dividing, everything you can do to an equality, there's no problem. But once you multiply by a negative, that's when an error appears. So you have to make sure you switch the inequality when you do that. And also, let's say, oops, sorry. Okay. Also, when you divide by a negative number, that gives us negative 36 divided by negative 2 is going to give us positive, because a negative divided by a negative is positive. It's going to give us positive 18. 12 divided by negative 12 divided by negative 2 is going to give us positive 6. Now if I leave this inequality there, now I definitely know 18 is not, a positive 18 is not smaller than positive 16. Because that's, remember, now this has to be the smaller side, this has to be the bigger side. So now it's wrong again. So I have to switch it back to the original one to get a true statement. That's true. So everything is fine. You just want to watch out for when you are multiplying or dividing by a negative. So let me put a note of that right here really quick. You want to make sure you switch the inequality when you either multiply or divide by a negative. Very important. So whenever you're multiplying or dividing by a negative for an equality, you want to make sure you change the inequality. Switch it. So, whoop. Stay. Alright. Let's actually solve some now. So let's start off with a small example. We don't have to go too crazy. So let's look at example 1. It's going to be negative 6x plus 4 less than 34. So here, just like how you're solving an equation, that means you want to isolate your variable. But to do that, you need to get rid of everything else that's around it. So we are going to have to subtract by 4 to both sides. And remember, subtracting, perfectly fine. There's nothing wrong with subtracting. Now, these cancel here. Remember that. Oh, no, not there. Sorry. This leaves us with still negative 6x. Less than. Again, I'm not changing the inequality when I subtract. It's only if I multiply or divide by a negative. That's going to give me 34 minus 4 is going to give me 30. And now I see that the negative 6 and the x are multiplying each other. So remember, whenever you're moving something to the other side, you have to use opposite operation. The opposite of addition is subtraction. The opposite of multiplication is division. But you want to make sure you leave the x. Well, I wrote that division sign all the way down there. you want to make sure the coefficient, well, the only number that's in front of this x to be isolated has to be a positive 1. So I need to divide by a negative to make it a positive, and I need to divide by 6 to convert that into a 1. So I just divided by -6. Now in this case, these don't cancel. They just simplify to that positive 1 that I want, leaving me with x is less than 30 divided by 6 is 6. -5. Sorry, got a brain fart there. But do you guys notice anything? Hopefully, again, talking to myself here, but hopefully you guys did notice something. I wanted to see if you guys catched it in the video. And hopefully you're screaming through the video, you forgot something. And remember, subtracting was fine. But when you divide by a negative, what are we supposed to do? Switch inequality if you're dividing or multiplying. So this is wrong. You're still left with that x, of course. But then I have to switch this less than to the opposite one, which is greater than. So if the problem started with this one, you switch it to the other one, and vice versa. If you started here, switch it to this one. If you started with this one, you switch to that one. If you start with this one, you switch to that one. Here, switches to this one, that switches to that one. So go back and forth. You're not going to go from less than to greater than or equal to. You just go to greater than. All right. Now I have my -5. And now this is true. Before, when we were solving equations, all we got was one answer. And that one answer satisfied the equation. But now, since this is an equality, there's many numbers that can satisfy the inequality. For example, here, I know 0 works, 10 works, because remember, this side, let's not forget, bigger, smaller, because it opens up to the bigger side, this is the smaller side. And I know something to keep note, positives will always be bigger than negatives, because the positives are on the right, the negatives are on the left. So I know any positive number will work here. So there's no longer just one solution, it's a set of solutions, because there's many numbers that will satisfy this inequality. And this is your answer. But just like how we did in the previous video, there's different ways to write your answer. There's actually 3. You can either graph it, you can write set notation, or you can use interval notation. So again, like last class, if we're going to graph this, the only number we have to reference is -5. And this doesn't have the equal to part. So that means if I plug -5 here, -5 is not greater than -5. So that would be a false statement. So you cannot include -5. But like we said, x has to be bigger. So those are all the numbers on the right. Now I can write this in set notation. X, I'm going to tell you about x, and that is that x has to be greater than -5. Interval, this starts at -5, and then it continues to positive infinity. But if we look back at the last slide, we see that, remember, parentheses always around infinity. And then if it was less than or greater than, meaning it didn't have the equal to part, you always use parentheses. And it didn't have an equal to part, or else I would have used the bracket. And there's my 3 solutions for the problem. Let's look at another example. I'll be posting homework on this, not yet, but I'll put a couple problems up for you guys to try. But here, let's try another example. Let's see what would be another good one. Here, let's try negative 5t, then always have to be x. Negative 5t minus 6 is greater than or equal to 24. So, alright, to move that 6 over, same thing. Add 6 to both sides. Here it actually cancels. In this situation, it's simplifying, so don't mix that up. So now we have negative 5t greater than or equal to 30. And just like before, since they're multiplying, the opposite operation of multiplication is division. And I'm going to divide by an entire number, which is negative 5. And again, you are dividing by this negative 5. So that means this will simplify to 1. But then we also have to switch that inequality, which is going to be t less than or equal to negative 6. And then we can write our solution. So the first one is you can graph. The only number I have to reference is negative 6. And it has the equal to part. So that means I can actually include that negative 6, meaning it's going to be a closed circle. And then t is also smaller than negative 6. So those are all the numbers to the left. So when I write my set notation, that's just going to be x such that t. Oh, see, I'm messing up myself. I said at the beginning, it doesn't always have to be x. So the variable in question is t. And I'm going to tell you about t. That it has to be less than or equal to negative 6. And then, remember, this starts at, from least is negative infinity, stops at negative 6, parentheses, always around infinity. Since this is a closed circle, that means we can include negative 6 in here. That implies a bracket. Alright, let me see if I can fit one more example here, a small one, just so you can see something slightly different. Let's say we have negative 1/4 t less than 2. So now to simplify this 1/4, I want to multiply, because technically that 4 is dividing. So to simplify, I have to multiply by negative 4 to both sides. So again, since this is going to simplify to 1, which is going to leave you with your t. But then you have to change this inequality. So that's going to be greater than, because we're multiplying. That's why I have to switch it. I'm multiplying by negative. Either you multiply or divide by negative. You want to make sure you switch that inequality. So that's going to be greater than negative 4. Oops, sorry. 8. Because 2 times negative 4 is negative 8. And same thing, if you were to do your 3 solutions, negative 8. I can't include negative 8, so I have an open circle, and it's everything bigger than negative 8. Set notation, t such that t is greater than negative 8. Interval notation, negative 8 to positive infinity. Parentheses around, always around infinity, and then since you can't include 8, parentheses around that as well. So sorry, I just tried to squeeze that in there. But that's how you solve inequalities. Just 2 more examples. But we're going to look at compound inequalities. all compound is telling us is that we're going to put two inequalities together. But when we write their solutions, we want to make sure that we're satisfying both of these inequalities. So let me just start with an example, since we have everything else that we need already. Let's have 5 is less than negative 2x plus 7 less than or equal to 11. So, oops. Sorry. These are what I mean. Here are two inequalities that we need to satisfy. So I can cover one up, and then you solve that one like how we just solved in the last one. So that would be subtract 7 to both sides. But then if I cover this side, I'd also want us to subtract 7 to that left hand side. So you're ultimately subtracting 7 from all three different parts: the left, center, and the right. So what ends up happening here, 5 minus 7. So don't get that mixed up. I'm not multiplying, I'm not dividing by a negative 7. I'm subtracting 7. So that leaves me with negative 2 is less than or equal to, here this cancels, negative 2x. On this side, again, we're just subtracting, so inequality stays the same. I'm left with 4. Again, now I want to divide by this negative 2, but I'm not only doing it to both of these sides, I also have to do it to this side, just like if it was a two different inequalities solving at once. But now I'm dividing by a negative. That ends up making this 1, positive 1, but then I have to switch this to greater than. This simplifies to just x. Whoops. But then I have to switch this to greater than or equal to. This becomes negative 2. And again, I'm doing everything based off bigger or smaller, just like before. I only have two numbers to reference, negative 2 and positive 1. And I know 2 is bigger. Negative 2 is smaller than 1. So I know it has to be on the left. Again, I'm not spacing it out exactly. I just have only two numbers to reference. And I know the smaller ones are on the left, bigger ones are on the right. So negative 2 have to be on the left, positive 1 have to be on the right. But now I have to satisfy both of these inequalities. So not only this one, which says x can be equal to negative 2. So then that's going to be a closed circle here. And then everything bigger, because x has to be bigger than negative 2. And bigger numbers are on the right. But then I also have to satisfy this side, where it says that x cannot be equal to negative 1. To positive 1. So I'm going to have an open circle here. But then, again, don't worry about what direction this is pointing. I go back to our original. So that inequality is this one. That's the smaller side. That's the bigger side. Doesn't matter if the x was, because all the other ones we were looking at, the x was on the left side. Still the same. X has to be smaller than 1. Where are the numbers that are smaller? Always on the left. But now we have to look at where these two overlap each other. And they overlap starting at negative 2. And they continue overlapping all the way up to 1. But remember, this inequality included 1, but this inequality didn't. So Again, think about roommates. Whenever you have a roommate, when you're buying food or paying bills, everything has to be divided equally, or you guys have to compromise on things, and they're both okay with -2. They're both okay with everything in between, but since one of them's not okay with one, so the other one's not going to be okay with it either. So they're compromising each other to give you and that would be your graph, this one right here. That one, that would be the graph. But you can also do set notation. So the graph set notation would be your braces, X, such that, and then you just put all that in there. And then interval, same thing, least to greatest. This starts at -2. It stops at 1. But I can actually include -2. And I have a closed circle at -2. So that's going to be brackets. I cannot include 1. And it's an open circle. That means parentheses. So let's just do one more. And that's going to be this other one. Let's try -16. And then that would be it for this video. Sorry, lost the problem. Less than or equal to -3y minus 4 greater than or equal to 2. So same thing. I want to solve. I need to add 4. But I also need to add it to the other side. Left, center, right. Here I'm just subtracting, so don't think that's division. You have to say the division symbol. That's going to give me oops, I'm doing it in red, -20 less than or equal to, this cancels here, -3y less than 6. Now I want to divide by -3. Now I'm dividing by negative. So that's going to give me, oops. Copy everything correctly, yes. I just made a mistake. I hope you guys noticed it. Here, I added 4. And on this side, for some reason, I subtracted by 4. I'm not sure why I'm supposed to add by 4. So this is technically supposed to be -12. Now, -12, and again, it doesn't always have to be a nice number. You could end up with fractions. There's nothing wrong with ending up with fractions. But I did make a mistake. But if this was subtracting, -20 would have been fine. Divided by 3 would also be fine. Again, it doesn't go into it nicely, but I would leave it as an improper fraction that way. Now -12 divided by -3 gives us -4. But then I have to change this to greater than or equal to. That simplifies to just y. And then this simplifies to -2. But then I have to switch this inequality to greater than. Again, I only have 2 numbers to reference. I know -2 is bigger than -4. But then if I look on this side, it tells me that y has to be smaller than -4, but it can also be equal to it. So that's a closed circle here. But then y has to be smaller. So that means everything to the left. Don't always think it's going to be in the center. This one says y has to be, cannot include -2. So it has to be open to it. And then y has to be bigger. And that's how we're going to write it. Sorry, guys. I made another mistake. Again, if this was written, that would be perfectly fine. And we are going to, in the next video, look at examples that are like this. Again, I hope I'm not confusing you guys by making these small mistakes. I'm going to end the video after this just because if I continue, I'm probably going to make another one. Negative 12 divided by negative 3 has to give us positive 4, which then will be greater than or equal to y. And then this is all the same. The problem was it wasn't supposed to be negative 4. It was supposed to be positive. So that means the negatives are always on the left, positives are always on the right. Closed circle here, y has to be smaller. Open circle here, and then y has to be bigger. So it actually ended up being everything in between. So it would be, if you redid it over here, negative 2 and 4, it'd be open circle, closed circle, and then everything in between would be the solution. Set notation would just be x such that, or y, see, keep making mistakes, y such that 4 less than or equal to y greater than negative 2. And then interval notation starts at negative 2, ends at 4. Parentheses around open circle, brackets around closed circle. And yeah, let me just, don't forget, middle, left, right. And then smaller, bigger, bigger, smaller. Don't forget what the inequality is. Let me just give you your homework really quick. Alright, there's your homework. I didn't want to record while I was writing it, so hopefully you guys see it. It's 1.7, 9, 10, 11, 15, 29, 37, 38, 41. Not too many problems. We're still not done with 1.7. I still have to do the absolute value inequalities, but I'll save that for a later video. It's going to be, there's a lot more things to keep in mind, and I'd rather you work on this, and then I'll post another video maybe tomorrow or Friday. I'm not going to be posting videos just Monday, Wednesday, but just keep that in mind.